and all present here. Myself and Kalpana. I am from Sri G.k.Jain Higher Secondary School, Roypuram. Today for the 10th standard I am going to explain the topic is periodic classification. In last part we saw about the important terms in the periodic classification. What it is period, what mean group, how many periods and groups are present, ionic radius, atomic radius, covalent radius, metallic radius, electronegativity, electron affinity. Okay, let's see. Now we have first to see the properties of metal. So metallurgy means we have to extract the metal from its ore. Okay, ores means we'll be having a large scales of metal will be present in it. Okay, let's see the properties of metal. Metal will be always be having in a solid state, except some other metals or some other thing only which has been in a liquid form. Okay, it is like a mercury and all, and it is always been in a lustrous. Lustrous means in a bright way, it shows in a bright way. And next one is hard. All the metals, especially all the metals are hard only, like sodium and potassium only. Sometimes it should be having cut it in a knife itself also. So except these only, because all the metals are hard in nature and will be having a higher density. Higher density means the thickness will be always higher in boiling as well as a melting point. And ductility means the metals can be easy to make it as a wire. Okay, like a copper make it as a thin wire, isn't it? That form will be called it as a ductility. And malleability, make it as a thin sheet. Aluminium will be make it a thin sheet. That process is called malleability. And it is easy to conduct the heat as well as the electricity. Okay, it is a good conductor of heat and electricity. Let's see the extraction of aluminium. Aluminium is been extracted from the bauxite. Bauxite is the chief ore for the aluminium. So the formula for bauxite is Al2O3 2H2O. Okay, let's see the first process is convert bauxite into alumina. Okay, you have to take the ore. Ore means bauxite in this place. So the ore which is reacted with the concentrated caustic soda, it has been added with that and it will be heated. Caustic soda. So the ore, it is treated with the caustic soda, concentrated of caustic soda which is under the high temperature. It has been heated. It should be formed as a sodium meta-aluminate. So in the sodium meta-aluminate, it will be with the water, it will be formed as a, so let's see the ore. Bauxite, it has been treated with the concentrated caustic soda. It has been heated. Then it will be formed the product as soda meta-aluminate. And the sodium meta-aluminate is treated with the water formed as the aluminium hydroxide. Later on, the aluminium hydroxide, it is yield the Al2O3 alumina, and the water molecules have been separated off. This is the alumina. So this is the process conversion of bauxite into alumina. And next process is an electrolytic process. Usually electrolytic process, in a beaker we have two chambers. One is a cathode and the other one is anode. It is filled with the liquid. You call it as a electrolytes. When you apply the electricity, the cathode and the anode react to the solution react together. In the cathode and the anode, it has been separated. For the separation, we have doing the electrolysis method. Let's see the same in the electrolysis method for getting the purest form of aluminium. Okay, first electrolytic, it is a Hall's process. So it is the first one is a cathode. So in this thing we don't have. Let's see, it is a beaker. Usually we have two rods, cathode and the anode. But in this process, here that the tank, that means the beaker, it is coated with the iron tank. It is an iron tank, which is not a glass beaker. It is an iron tank coated with the graphite, act as a cathode. So this is the cathode. And next one, again the graphite rod is suspended. We have suspended the rod. Suspended means we have inserted over it. It is an anode. It is also be a graphite. And next one, electrolyte. Usually electrolyte will be in a molten state. Here we are having a alumina plus molten state of cryolite and fluorspar. So this is the mixture will be taken. Then we have to apply the temperature or apply the volt of 5 to 6 volt in this thing. And next one, maintaining the temperature above 900 to 950 degrees Celsius. We have to maintain it. Then the overall reaction taking places, we have taken the alumina, Al2O3, which is formed as the aluminium. Let's see, this is the formula for aluminium. If we have taken as the aluminium in this process, alumina in this process, this is the Al2O3 is the alumina. So So it is be getting splitted as aluminium and the oxygen. So the aluminium, it will be deposited at the cathode, and the oxygen will be deposited in the form of it has been evolved in it in the form of anode. And usually we have the aluminium, it is reacted with the oxygen is there, it is treated with the graphite. Graphite means it is allotropes of carbon, so it will be like a carbon only. Allotropes means different in the physical properties. So carbon which is treated with the oxygen, it is formed as a carbon dioxide. After the extraction of aluminium, the extraction of copper and iron. The important ore for the copper is copper pyrite. The formula for copper pyrite is CuFeS2. Okay, let's see the steps which is involved for the extraction of pure copper. First step is concentration. The concentration, it is by the froth flotation process. So we have to take the ore, it has been crushed in it, taken in a beaker, it is filled with the ore, and you have to add the water as well as the oil. Then you have the collector will be present in it. If you stirrer will be, stirrer means used to mix together. If you fastly have stirrer, the oil with the water, it will be form the foamingness. Automatically the one type of the ore will be deposited at the foaming, the other unwanted material will be deposited at the water, and under it has been settled down. This is the froth flotation method, flotation. And next one is a roasting. Roasting means the copper, you have taken the copper pyrite, you have been heated in presence of oxygen. Roasting means in presence of oxygen to form copper sulfide. Sulfide ores it has been formed. Copper sulfide ores of copper and the iron will be formed. And next one is a smelting. In the smelting you have ore, it is treated with the coke. So usually the unwanted sulfide ores have been removed as a slag. Slag means unwanted things has been removed. And next one is a Abysmal Ization. So in this Abysmal Ization we have copper sulfate, the unwanted things, and treated with the oxygen, formed as a Cu2O. In presence of sulfide, it has removed by the oxygen Cu2O, and sulfur dioxide has been evaporated. It has been vaporized. And next one, it has been removed out. It is also be formed. Okay. And next one, Cu2O, it is treated with again the Cu2S. Again you have to do it in the same process. You will be getting a purest form of copper, 6Cu plus evolved. Sulfur dioxide will be evolved in it. Okay, this is the process will be happen in the Abysmal Ization. And next one, electrolyted. In last step in aluminium also we saw the electrolyted. It is used to getting a purest form deposited at the cathode or anode. So here you have taken a cathode, a thin plate of copper metal we have taken. In an anode, pure or impure copper metal we have taken, and the electrolyte copper sulfate treated with the sulfuric acid formed as an electrolyte. So then after we have supplying the electricity, you have get it a purest form of copper. This is the process involved in the extraction of copper. Now we have seen the iron. So the extraction, the chief ore for iron is hematite, Fe2O3. Again the concentrated by gravity separation. In a gravity separation means you have taken a ore, crushed in it, just in a running water you have introduced in it. For the higher lesser in the gravity, it is flowing off. The higher gravity substance will be settled over there. That means the ore can be, the ores will be fall off, and the unwanted material will be settled over in the slopy flow. Okay, that is concentrated by the gravity separation. If you have placed in the water, tap water, something unwanted will be removed. The same will be done it in the first step. Second one is a roasting and calcination. Roasting and calcination, here you have seen in the copper, roasting means the ores, it has been heated in presence of oxygen, isn't it? The same. Roasting means in presence of oxygen. Calcination means absence or limited supply of oxygen. Both it has been in the same way. We have heated in presence of oxygen or supply. Say third one is a smelting. In a smelting, again the ore, it will be coke, limestone, 8:4:1%. It has been getting into the large furnace. We have a 3 region in it. Let's see, in a lower region, carbon which is treated with the oxygen under the 1500 degrees Celsius, it forms the carbon dioxide. It is an exothermic reaction. Exothermic means a wall of heat will be evolved in it. And next one is in a middle thing, again the carbon dioxide, again it has been treated with the carbon to form carbon monoxide. In the upper region, the pyrite hematite will be treated with the carbon monoxide. Step by step it has been formed. From the lower it formed carbon dioxide, in the middle carbon monoxide, and the formed carbon monoxide treated with the hematite to getting as a purest form of iron. This is the simple, very easy, and it is important. The three the expected questions are extraction of aluminium, copper and iron. In 1 mark or 2 mark they are asking the what is the ore for the copper and iron or aluminium. The important definition we go through, no, the same it is also been in the 2 marks we have expected this. Thank you.